I can turn a fraction into a decimal using long division. To turn a fraction into a decimal, you should divide, and the numerator or the top goes inside the division symbol, and the denominator or the bottom goes outside. So for example, 3/4. The 3 is going to go inside the division symbol, and the 4 goes outside. Now, most of the time when you set this up, if this is a proper fraction, we're going to get a 0 because 4 cannot go into 3. So I'll put a 0 up there. There is a decimal after this 3. It is 3 point. So I'm going to include that, and I'm going to bring it up. Now that I've done that, I can ignore the decimal, and it will just be up there, my answer. And I can add as many zeros after I want on this until it either terminates or repeats. So I'm going to add a 0 here, and then I'm just going to say 4 goes into 30 how many times, ignoring that decimal again. So 4 goes into 30 7 times for 28. Subtracting, I can add more zeros and bring them down. 4 goes into 25 times, and that is going to terminate right there. So my answer to 3/4 as a decimal is 0.75. Let's do 1/8. So the top goes inside the division sign, the bottom goes outside. 8 can't go into 1, so I'll put the 0. There's always a decimal after a whole number here, and I'm just going to bring it up, and then I don't have to worry about it anymore. And I can add zeros down here. So 8 into 10 would go in once. 10 minus 8 is 2. I can keep adding zeros, bringing them down. 8 goes into 20 2 times. Subtract, bring down another 0. 8 goes into 40 5 times, and it is going to terminate right there. So 1/8 as a decimal is 0.125. 5/6. Now 5/6 is not going to terminate for us, but we do it the same way. Top goes inside, the bottom goes outside. 6 cannot go into 5. I can add my decimal and bring it up, and then I can add as many zeros here after that decimal as I want inside the division sign. So 6 into 50. That's going to go in 8 times for 48. Subtract. I can add a 0, bring it down. 6 goes into 20 3 times. I can add a 0, bring it down, and I am seeing a pattern, but you could do this as many times as you need to do to see that pattern. You can keep adding zeros, bring them down, but each time 20, 20, 20, and this time when I do it, I'm going to get another 2, and it's just going to keep going. So my answer, I'm going to write it as 0.83, and then we need to acknowledge that that 3 is just going to keep repeating. So I put this line over the top, and that says the 3 is repeating. And make sure that line does not go over the 8, because then you would be saying it goes 8, 3, 8, 3, 8, 3. But I only want 1/8, and then repeating 3s after that. And we need to acknowledge that. We can't just round it off if they're looking for an exact decimal. Okay, 2/7. So the 2 is going inside, the 7 is going outside. I can't do that, so that's a 0. I'm going to have my decimal there and bring it up. And I can add a 0. That's going in twice. And I can subtract. Seven goes into 60. Subtract. I can keep adding zeros and bringing them down. 7 times 5 is 35. Subtract. Goes 7 times. I'm going to bring it up here just because I ran out of room. So I had a 1. I'm bringing a 0 down. So now 7 goes into 10 one time. Subtract. Add a 0. 7 goes into 30 4 times. And now I'm back to the beginning again. Notice how I started with that 20. I've got another 20. So it's just going to repeat this pattern, because when I put a 2, I get 14. I get that 6 again, and it's just going to go on. So when I write this one, this is going to be 0.2857714. And that whole thing repeats. So I'm going to have a line over that whole thing to say that it's a repeating pattern that just keeps going. These ones should all terminate or repeat, But as you notice, it might repeat one digit over and over, or it might repeat a series of digits all over.